We now learn about something that is very typical for the Python programming language. It's a tool called list comprehension, and it's actually very useful. Consider the following situation. You have your list 1 here with the elements 1, 4, 6, and 9, and you want to have a new list with all these elements raised to the power of 2. Now you could use your knowledge of for loops to write this for loop here, which goes through the single elements of list 1 and appends these elements raised to the power of 2 to list 2. This definitely works, but there is a second, actually easier and more efficient way in Python called list comprehension. You could also write list 3 and then create a new list, and the elements of the list should be the elements of list 1 raised to the power of 2. So you just take this here and you conduct this operation for all I in range len list 1. So it is very similar to what is written here, but it fits on one line and it's much easier to read. And if you execute all this and you print list 3, you actually see that it contains the same elements as list 2. But writing for loops as a list comprehension is usually much more readable. It's easier, and there are also some deeper reasons to do it because it is basically more efficient, which is important if you do more complex operations. So whenever you are thinking about writing a for loop, you should also consider writing it as a list comprehension. The final thing we learn about here are while loops. While loops repeat a certain action until a certain condition is met. We will only consider while loops with a very simple example. Now consider we want to count down from 10 to 0 and then print a string. To do this, we can define a variable counter and give it the value 10, and then we have to define a certain stop condition. In our case, this is 0. Now we can write a while loop by first using the keyword while and then writing the condition which must be fulfilled until the while loop should stop. So in our case here, the counter should be greater or equal than the stop condition. So unless this condition is fulfilled, Python will execute all the commands that come in the body after the colon in the next line, which also must be indented. So what happens here, we might want to print the counter, and we also need to change the counter, because if we execute this, Python will actually go on running forever because the condition will always be fulfilled. Let's see how that works out. We actually see here that Python executes this code all over again and always prints the 10 here, which is associated with the name counter. Now to stop this, we can press the stop button here and we can continue to work on our while loop until it is more useful. So what actually should happen is that in every iteration, the counter should be reduced by 1. And we could write this either by redefining it from scratch, or we can also use an abbreviation for this, which works like this. Now if we execute this, we actually see that Python here conducts what is written in the body of the while loop unless this condition is not met anymore, and it's not met anymore when the counter has reached the value of 0. If we change the stop condition here to the value of 5 and we execute all this, we actually see that Python execute the body of the while loop only until the counter has the value 5, because that is actually what is written here in the stop condition. We can enrich this while loop with an else statement here in the bottom. And this else statement is executed when the while loop is finished, but not before. Let's see this. Okay, So you will use while loops, for example, if you want to approximate certain mathematical operations, and there is a nice example about this in the script. But for here, we are going to finish with the loops, and now actually approach the end of the introductory lessons and simply have a look at different modules and namespaces in Python.